Lesson 9.4, real numbers. We're going to be talking about the rational numbers and the irrational numbers. Those are two subsets of real numbers. Okay, as a real number, we have rational numbers, and rational numbers, any number that can be written as a ratio. So you see the word ratio hiding in rational. Also, any decimal that is terminating, that means ends. So 0.2, 0.25, 0.1006, um, those all end. Or if it's a repeating, we can write it. So, 3, 3, 3, 3. We usually write that as 3 with a bar over it because that lets us know it's repeating. So those are all rational numbers. Integers are rational numbers, whole numbers are rational numbers, counting numbers, all of those are all rational. Irrational cannot be written as a ratio. So think about when someone's being irrational. They're not following a normal thinking or they're not reacting a certain way. So they're not going to be a ratio. Remember, by the way, ratio is just a fraction. So if it can or cannot be written as a fraction is really what we're looking at. So a rational can, an irrational cannot. Decimals that do not end, so pi, 3.1415962, I may have had a couple numbers backwards there. That is an irrational. It keeps on going and going and going. And it does not repeat. So it's not ending and it's not repeating. We can't write that as a rational number. Basically, there's no rational way of handling it. Okay, we have a couple jobs here. First, we need to find out which numbers are rational or irrational. Well, I kind of give you a hint up. There's a couple we know we can immediately get rid of out of here. We know one or two things about it. I said pi is irrational, so we're going to write an I for irrational. If it can be written as a ratio, we know it's rational. So immediately we have two of these done just because I know ratio is rational and pi is irrational. So now we need to do some work. You may use your calculator for some of these and see what you get. Let's try this one because this one looks a little scary, but let's not let it be. Is 10 a perfect square? Sorry, is 100 a perfect square? And it is. It's 10 times 10. How about 16? Yes, it is. It's 4 times 4. So I can simplify this to, and that should be a 10, not 11. Oh, it was a 4. I see. Sorry about that. So I see I have two 10s and two 4s. I know I can rewrite this one as 10 over 4. I'm not asking you to simplify it or anything at this point. So is this rational or irrational? It can be written as a fraction. It can be written as a ratio then. So it is a rational number. Excellent. So we have 3 more to go. Well, I'm going to suggest you use your calculator for this one and put it in. Okay, that number that you're getting, is it just a continual decimal with no repeating? That's correct. So you have an irrational number. Let's come over to 100, square root of 144. Hopefully you know from your list of perfect squares, this is actually going to be 12. But if you didn't, you could put it in your calculator and you see that you would get 12 because 12 times 12 is 144. So since that's my answer, I have a rational number. What about the square root of 1? It's a trick. It's rational because 1 times 1 in fact gives you 1. So a square root of 1. So this one is actually rational. Don't let it trick you. It's often easy to say, oh, well, that's not. But it is. Okay, let's go to the next. One of the other things you're being asked to do is to compare them on the number line. This is the number line for all real numbers. All real numbers consist of irrational and rational numbers. So let's see, one of the easiest ways to do this is to make sure you get them all in the same format. You can see I have fractions, I have square roots. That's not going to make my life easy. One of the best and easiest ways, usually taking it to decimals, but sometimes to the fraction equivalent. But decimals, take it out past a couple places so that you can easily compare them. When you put in negative, square root 3, you're going to get a negative 1.73205 continuing. And when you put square root of 7 in, you get 2.64575. When you find out 21 divided by 8, you get 2.625. You can see immediately why I needed to go past that tens place, because right here, these would have looked like they were the same. Negative 9/5, when I put that in, I get negative 1.8. So I'm going to plot these points now that they're all in a decimal fraction, equivalents. They're not going to be exact, but they're going to be close. So let's see, 1.8, negative 1.8, that's going to be really close to 2. And I'm going to change colors as I go so that we can see the different points, especially when they're close. Negative 1.8 I did, negative 1.73, then I have 2.64 is going to be less than 2.65. So, and I'm just approximating. I know that's a little bit more than half. Um, a lot of times this is going to be close to approximations. And then 2.625, oops, that's right there. 2.64575 is greater than that because 4 is greater than 2. So it's going to be right there. And we've plotted our points. Hopefully you'll find that this lesson wasn't too bad. It's really just taking it down to decimals and comparing and determining is it able to be written as a ratio. Thank you.